It's clear to me now that the limitation that I have here is because the data type for the instructions are defined as integer. So what do you think of changing the data type for the multiply instruction to double integer or long integer? By doing this, as you can see, the addresses that I've assigned for this instruction are going to become red to let me know that the data type for these addresses no longer match the data type of the instruction. For instance, if you look for the address assigned for the input in the tag table, you'll see that the data type for MW2 is Word, which is a 16-bit data type and does not match with double integer, which is a 32-bit data type. The same goes with MW4, the address assigned to the output. As you can see, the data type for this address is integer, which again is 16-bit and does not match with 32-bit double integer data type defined for the instruction. So I'm thinking that, to make this work, I can convert the data type for the addresses assigned to this instruction. That means I can convert the current data types, which are 16-bit, to 32-bit data types for the addresses to match with the data type of the instructions. So let's review what I'm doing here again. As I said, I'm thinking that to overcome the limitation for this instruction, I can change the data type to double integer. When I did that, I realized that the data type of the addresses assigned to this instruction do not match with the new data type that I've defined. So now I'm thinking of converting the data types for the addresses as well. So to do that, I'm going to add a convert instruction after the second counter in the first network. With this instruction, I'm going to convert the data type for MW2. So I will assign this address to the input. The data type for MW2 is Word, but here, since I don't have this data type for this instruction, I'll select integer. For the output, I'll assign a 32-bit memory address like MD20 and define the data type as double integer. This instruction is going to convert the data type of the value within MW2 to double integer. Now, I can replace the address of the multiply input with the new address, and as you can see, it will be accepted without any problem. I should also change the address for the output. So, I'll replace MW4 with MD40 here as well. Now that I've changed the addresses for the multiply instruction, I should also change the addresses for the add instruction. So, I'll replace MW4 with MD40 here. Then, I will also replace MW6 with MD60. For MWO, since this is the value that comes from the C1 output, I cannot just replace it with a 32-bit memory address. For this address, I need to do what I did for MW2. So, in the first network, I'm going to add a branch after C1, and then add another convert instruction. I'll assign MWO as the input address and MD10 as the output address. Just as I did for the previous instruction, I'll define the data type as integer for the input and double integer for the output. Now, I'm able to replace MWO with MD10 for the add instruction here. I will also define the data type as double integer for the instruction. Now, let's download the software to the simulator to see how it works. In the online mode, if I modify the display format for the first counter's output, you'll see that the accumulated value for this counter is currently 1, and the accumulated value for the second counter is 34. This convert instruction is converting the value within the C1 output to a 32-bit value. The other convert instruction is doing the same for the value within the C2 output. If I scroll down to the next network, you'll see that the ENO output for the multiply instruction is now true, which shows that the instruction is working properly. This instruction is multiplying the accumulated value of C2 by 999. At the same time, the add instruction is adding the result of the previous operations with the C1 accumulated value and puts the result into MD60, which is now the total accumulated value counted by the two counters. So, by adding two simple convert instructions to this program, I can pass the second limitation as well.